Yes, we will start. Now it is exactly 10:10. Yes, yesterday we are discussing about the dehydration of alcohols to alkenes. Dehydration means removal of water molecule. So this is the 11th standard reaction. In 11th standard, we already learned this reaction, dehydration. It is elimination reaction. The OH atom bonded to the carbon. This carbon is called as alpha. And nearer to alpha, this is beta. So alpha from the OH and beta from the hydrogen, it is removed by using the reagents. Remember, the dehydrating reagents are sulfuric acid, then phosphoric acid, alumina. These are used as removal of water molecule, and the reaction takes place according to this order. Tertiary alcohols reacts first, then secondary alcohol, and then the primary alcohols. So these are the examples are given here. In case of primary alcohols, we get only one product. We have to use 75% H2SO4. In case of secondary alcohols, see here. In case of secondary alcohols, we see yes, 60% H2SO4 is used, and we get the two products here because the two beta hydrogens are there. If this beta hydrogen is removed, this beta hydrogen is removed, and this OH is removed, we get this product according to the Sedgwick's rule. Sedgwick's rules already we learned in the chapter halogen derivatives. What is the Sedgwick's rule? I will explain again. In case of elimination reaction, the compounds which contains maximum number of CH3 groups bonded to the double bonded carbon, this is the major products, and this is a minor product. See, this is a minor one, and this is major one because the two CH3 groups are there bonded to the carbon-carbon double bond, and in this there is only one. Sorry, in this there is no any CH3 group. So this is minor, and this is a major. So this is a dehydration of alcohols. Already it is learned in 11th standard. This problem, no any question will be asked on this problem. This is given just for practice. Those students who are interested, they can solve at their home. Then the next reaction is oxidation of alcohols. Oxidation of alcohols, say, I will give one hint to you. Alcohols on oxidation gives aldehydes and ketones, and aldehydes ketones on oxidation gives carboxylic acid. Remember this chart. So first one, secondary alcohols gives ketones, and primary alcohols on oxidation gives aldehydes. There are many oxidizing agents like nitric acid, potassium permanganate. See in the below, it is given nitric acid, HNO3, potassium permanganate, and potassium dichromate. These are the very strong oxidizing agents. So if the strong oxidizing agents are used, they gives aldehydes, and aldehydes again oxidation gives carboxylic acid. But if you want to stop the reaction at this aldehyde stage, we have to use the mild oxidizing agent. This is PCC. PCC, it is a pyridium chlorochromate. It is a mild oxidizing agent which stops the reaction at aldehyde stage. If instead of this PCC, if you use the strong oxidizing agents like nitric acid, like potassium permanganate, like potassium dichromate, we will get the product carboxylic acid C. Why the carboxylic acid is formed here? Because primary alcohols on oxidation gives aldehydes, and aldehydes again gets oxidized to get the product carboxylic acid. So these are the strong oxidizing agents. When it is used, we get the carboxylic acid products, and when the mild oxidizing agents are used, we get aldehydes. So primary alcohols gives aldehydes, secondary alcohols gives ketones. Remember this one. Instead of this, we can use CrO3. This is also the mild oxidizing agent, CrO3. It is chromic anhydride. Then in case of tertiary alcohols very difficult to oxidize because there is no alpha hydrogen. See here, alpha hydrogens are there. this OH is attached to this carbon. There are two alpha hydrogens are there. In this secondary also, there is one alpha hydrogen is there, but in case of tertiary alcohols, there is no alpha hydrogen. That's why it is very difficult to oxidize. First they are converted into alkenes, and alkenes again oxidize to give the carboxylic acids. The next one is heating with copper. This when the alcohol vapors are passed on copper, they gives primary alcohol, secondary alcohols, and tertiary alcohols. There are three alcohols I will explain. Primary alcohols on oxidation gives aldehydes, secondary alcohols on oxidation gives ketones, and the tertiary alcohols on oxidation gives alkenes. So this is same as previous one. This is only oxidation with copper. Then reactions with phenol. One thing we have to remember here, in case of copper, the temperature conditions are same, 573 for primary, 573 for secondary, and 573 for tertiary. See in this tertiary alcohols, clearly it is seen here, we get alkenes here. And alkenes again oxidation gives carboxylic acids. Then the reaction with phenols, reaction of phenols. Already you know this OH group attached to the phenol, it is electron donating. This is electron donating, so always it activates the ring. We get one is ortho and para compounds, mixture of ortho and para compounds. Halogenation of phenol. Halogenation means nothing but addition of halogens. It takes place by two ways. Bromine water. Always remember, when the bromine and water is mixed together, we get here 2,4,6 tribromophenol. The same reaction is carried out with chlorine water also. If 3 molecules of chlorines are taken here, we get 2,4,6 trichlorophenol. So remember, when bromine water is used, we get here at second position, fourth position, and sixth position, bromine is attached. And if bromine water is not used, we get ortho and para products here. See, bromination takes place in carbon disulfide, or you can use the CHCl3 as a solvent. CCl4 it is used as a solvent. We get ortho and para, and always remember, out of these two, ortho and para, this para is always major product because there is no steric hindrance. OH and Brs are away from each other, they do not interact. But in case of this ortho, OH and Br, these are closer, so they can hinder each other. So this is a minor product and this is major product. Always remember, this phenol is ortho para directing group. So one hydrogen from ortho and one hydrogen from para, it is removed. Then the nitration of phenol, this is very important. Those students are preparing for CET and NEET exam, this is very important. This question is asked for many times for the board exam. Nitration of phenol. See, phenol reacts with a dilute. First, it reacts with dilute nitric acid at low temperature to give ortho and para. This is a normal reaction. This is ortho and para. But this is this orthonitrophenol having the intramolecular hydrogen bonding here. So what is intramolecular hydrogen bonding? I will explain. And this, in case of para-nitrophenol, there is a intermolecular hydrogen bonding. Intermolecular hydrogen bonding means between the two different molecules, and intramolecular hydrogen bonding means between the same molecule, the bonding is there. So see, in case of orthonitrophenol, there is a intramolecular hydrogen bonding. Intramolecular hydrogen bonding means between the same compound, and intermolecular hydrogen bonding between the two molecules, the hydrogen bonding is there. This question is asked for NEET exam in case in year 2018 for 4 marks. What was that question? How this orthonitrophenol and para-nitrophenols are separated? Which of the following method is used? So this orthonitrophenol and para-nitrophenols are separated by the steam distillation process. Remember, for this word steam distillation, it is having the 4 marks for the NEET exam 2018. It is asked steam distillation, crystallization, and then fractional crystallization. These are the options. The steam distillation, it is the correct answer, because orthonitrophenol is a steam volatile. So the bonding is there. Orthonitrophenol, the intramolecular hydrogen bonding is there. This is due to the intramolecular hydrogen bonding. This is steam volatile. It will be escaped with the steam. And the paranitrophenol, it is less volatile due to the intermolecular hydrogen bonding. See, this is the intermolecular hydrogen bonding, and this is the intramolecular hydrogen bonding. When intramolecular hydrogen bonding is there, always these are volatile. And when the intermolecular hydrogen bondings are there, this is having the more boiling point, and this is having the very less boiling point. Then when phenol is treated with a mixture of concentrated nitric acid and concentrated sulfuric acid, it gives 2,4,6 trinitrophenol. So there are two nitrations, nitration with dilute HNO3 and nitration with mixture of concentrated H2SO4 and mixture of concentrated HNO3. We get here only one product. The name of the product is picric acid. Picric acid is nothing but 2,4,6. It is a 2,4,6 trinitrophenol. It is yellow colored compound. This reaction is also important, remember. Then next one is sulfonation of phenol. Sulfonation means introduction of SO3H group. All these sulfonation, nitration, then Fidelkraft alkylation, Fidelkraft acylation, these reactions we already discussed in 11th standard. Also we discuss in the chapter number 10 halogen derivatives. Also we will discuss in this chapter. Again we will discuss in ethers also. Again we will discuss in amines also. So many times this nitration, sulfonation, Fidelkraft alkylation, then halogenation, these reactions will be repeated. But the product will be different. The product will depend upon the group attached to the benzene ring. If the group attached to the benzene ring is orthopara directing, we get orthopara product, and group attached to the benzene ring, if it is electron withdrawing, we get only one product, meta. Electron donating, we get two products, ortho and para. If the group attached to the benzene ring is electron withdrawing, we get only one product, meta. Remember these things only. Already this is given in chapter number 15, aromatic compounds in 11th standard. So sulfonation is nothing but introduction of SO3H group. See, SO3H group, when the temperature conditions are different here, when the temperature is 293, we get the ortho product, and when the temperature is 373, we get the para product. Always this para is major and ortho is minor due to the steric hindrance. Then next one is a Riemer-Tiemann reaction. Riemer-Tiemann, these are the name of the scientist who discovered this reaction. These two reactions are very important, Riemer-Tiemann and Kolb's reaction. This is asked for 2 marks. This is also asked for 2 marks because these are the name reactions. Always name reactions are asked for 2 marks. So this is asked for 2 marks, and this is Kolb's reaction is also asked for 2 marks. So what is the reaction? I will explain. When this phenol is treated with chloroform, it is used as a solvent, and aqueous NaOH, these are used as a solvent. We get first here intermediate. Intermediate, in this intermediate, this is a sodium phenoxide. It is formed, and at the ortho position, CHCl2 is attached. This is intermediate. When this intermediate is hydrolyzed with NaOH, we get here aldehyde. And aldehyde, again hydrolysis with acid, we get salicylaldehyde. But remember one thing, if instead of this CHCl3 chloroform, carbon tetrachloride, if it is used, we get the salicylic acid is the product. Means instead of this CHO, we get here COOH group, salicylaldehyde. Instead of this salicylaldehyde, we get salicylic acid when carbon tetrachloride is used. This is a Riemer-Tiemann reaction. Then next reaction is Kolb's reaction. In case of this Kolb's reaction, it is a nearly same as Riemer-Tiemann reaction. Sodium phenoxides when treated with carbon dioxide. See, this is the sodium phenoxide, and how this sodium phenoxide is prepared? We have to take phenol, then we have to add NaOH, then the sodium phenoxide is formed. This sodium phenoxide is treated with CO2. This is carbon dioxide at the temperature is 398, and the atmospheric pressure is 226 atmosphere. And we get here CONA groups. This is sodium salicylate after hydrolysis, acidic hydrolysis. H3O plus means H2O plus acid. This is called as acidic hydrolysis. We get here COH, salicylic acid. This is a Kolb's reaction. In Kolb's reaction, we get acid, and in Riemer-Tiemann reaction, we get aldehyde. This is a different. Don't get confused between these two. In case of Riemer-Tiemann reaction, also we can get the salicylic acid. But we have to use here, instead of CHCl3, we have to use carbon tetrachloride, then we will get the salicylic acid. Then oxidation of phenol. Oxidation of phenol is a very easy method. For this reaction, we have to use the strong oxidizing agents like chromic anhydride, CrO3, or you can use sodium dichromate, or you can use the potassium dichromate using H2SO4. We get here benzoquinone. Remember, it is benzoquinone. Quinone is 1,4-diketone, means at the first position and at the fourth position, ketones are there. This is at the carbon number 1, and this is carbon number 4. Quinones are there. Then catalytic hydrogenation. Catalytic hydrogenation means using catalysts like Raney nickel or platinum, palladium. Hydrogenation means addition of hydrogen. We get here cyclohexanol. All these bonds are removed. See, phenol, it is converted into cyclohexanol. This reaction is also completed in the chapter number 15 last year. But in this chapter, there was a hydrogenation of benzene. In this, there is a hydrogenation of phenol. So hydrogenation means addition of hydrogens. We get here one hydrogen, one hydrogen, one hydrogen, one hydrogen, one hydrogen. So thrice H2 means we are adding how many hydrogens? Thrice H2, 6 hydrogens we are adding. So already sorry, 2 hydrogens added. 2 hydrogens added. 1 hydrogen is already there. 1, 2, 3, 4, 5. Yes, here is 1 hydrogen is added here. So 6 hydrogens are added. Then reduction of phenol. Reduction means we have to remove this hydrogen, and this hydrogen is removed by using the zinc. Zinc reacts with phenol, we get the zinc oxide, and this oxygen is removed. These two reactions many times they ask for 1 mark and 1 mark. Sorry, this oxidation and reduction. Oxidation is carried out by using sodium dichromate, and reduction can be carried out by using zinc. Then preparation of ethers. Preparation of ethers in the halogen derivatives also we prepared ethers by using Williamson synthesis. We can prepare the ethers by using dehydration of alcohols also. Dehydration means nothing but removal of H2O molecule. See example carefully. When alcohols are heated, this is ethanol. When alcohols are heated with the dehydrating agent means which these agents removes water molecule. These dehydrating agents are H2SO4, then phosphoric acid, then alumina. In last reaction also dehydration of alcohols, we use these reagents. So dehydration of alcohols, ethanol, when it is treated with the dehydration, 2 molecules of ethanol, we get here dimethyl ether, diethyl ether, this is a common name, and ethoxyethane, this is a IUPAC name. So one more example is given here. If the temperature is 443, these ethers are formed at the temperature 413. At this temperature only ethers are formed. If the temperature is increased 443, then we will get the ethene, means water molecule will be removed. So remember, this is a limitation of this reaction. If the temperature is increased, instead of formation of ethers, we get ethene here. We get ethene. Then symmetrical ethers can be obtained by using primary alcohols by this method. Use of higher temperature or secondary tertiary alcohols gives alkene as the major products. Remember, when the temperature is increased, we get alkenes. So the temperature must be at 413, then we'll get the ethers. Then Williamson synthesis, this reaction is already we explained in the chapter number 10. So I am not explaining again in this chapter. By using sodium ethoxide and sodium methoxide, we will get the ethers. This Williamson synthesis already I explained in chapter number 10. This is same reaction. Then the physical properties, these physical properties are not asked for board exam, but I will explain within 2 minutes. Physical states and boiling points. Dimethyl ether and ethyl methyl ether, these are the gaseous, and other ethers are colorless liquids with ethers having the very nice smell, pleasant smell. Lower ethers are highly volatile. All the ethers are actually volatile. These are highly inflammable. They easily catches fire. Boiling point of ethers show gradual increase with the increase in molecular mass. See here, see the boiling points are increasing. See the boiling points are increasing here. This is a dimethyl ether. This is a ethyl methyl ether, and this is a diethyl ether. See the boiling point is increasing because the molecular mass is increasing. Polarity and solubility. Since COC bond angle is 110 degrees, COC we can see here, COC, this COC bond angle is 110 and it is not 180. So, yes, the bond dipole moments of the two CO bonds do not cancel each other. Therefore, ether possesses small net dipole moment. The small net dipole moment is 1.18 d by. These dipole moments are actually responsible for the solubility and polarity. So, ethers are weakly polar in nature. They do not affect the boiling points, which are same about the alkanes. We can see in this chart. This is alkanes. The N-heptane, this is alkane. This is methyl pentyl ether, say 102. This is the molecular mass. And what is the molecular mass of heptane is 100 degrees. And this is alcohols. One is alcohol, one is ether, and one is alkane. See the boiling point is 371 of alkane, and the boiling point of this ether is 373, and see the boiling point of alcohol is 430. The boiling point of alcohol is very high because there is a intermolecular hydrogen bonding, and this intermolecular hydrogen bonding is absent in the case of alkanes and ethers. That's why these are having the nearly same boiling points. The question may be asked for board exam, why the alcohols and ethers having difference in boiling point. So your answer should be, in case of ethers, the intermolecular hydrogen bonding is absent, and in case of alcohols, the intermolecular hydrogen is present. But ethers can be soluble. Ethers can be soluble in water because there is a ethereal oxygen. See, this is ether ROH, and this is H2O molecule. This is not actually the intermolecular hydrogen bonding. This is ethereal oxygen bonding. So due to this ethereal oxygen bonding, the ethers are soluble in water. Then the next part is reaction involving alkyl group of ethers. Reaction involving alkyl groups of ethers. See, in this alkyl group is involved. This is the diethyl ether if it is treated with oxygen. Means only the ether bottles are kept in air for a long time. They forms peroxides, and this peroxide is very dangerous. They catches fire. So ether bottles are always kept in a bottle with tap is there. So always remember, ether bottles do not be kept open, because if these are kept open, they react with atmospheric oxygen, and the peroxide is formed, and this peroxide is very dangerous. It decomposes violently at higher temperature and catches fire. So only one thing we have to remember: peroxide, oxygen reacts, peroxides are formed. We can take here any example. One example is shown: diethyl ether. This is a diethyl ether. This is C2H5. This is also C2H5. O2 is there. So we get CH3, CH, OH. This is a C, peroxide is formed here. Two oxygens are bonded. So this is a peroxide of diethyl ether. Make a practice using ethyl methyl ether. Make a practice using different ethers at your home. Then this is a simple hydrolysis. This is ether. When treated with water, they give alcohol. See, one example is ROR. This is same alkyl groups are there. This is ROR dash, different alkyl groups are there, and this is AROR, aromatic, and one is alkyl group. So in all these three reactions, we get here alcohols, we get here two different alcohols, and in this reaction, we get one alcohol, and one is alcohol and one is phenol. So this is a simple hydrolysis. When ethers are hydrolyzed, we get alcohols and phenols. This is reaction with PCl5. When ethers react with PCl5, we get one is RCl and another one is R-Cl. One is alkyl halide, second one is alkyl halide, but with a different R group and POCl3. We can take here any example, ethyl methyl ether or diethyl ether. We get two different alkyl halides. If the different R groups are used, the different alkyl halides are formed. If the same R groups are used, same alkyl halides are formed. Then reaction with hot concentrated acids. They may be hydrochloric acid, they may be hydrobromic acid, they may be hydroiodic acid. The reactivity of acids is like this. HI react very fast, then HBI react, and HCl reacts very slow. So if these ethers react with HX, it may be HCl, it may be HI, or it may be HBr. We get one molecule of alkyl halide and one molecule of alcohol here. This bond will be broken. This bond will be broken. OR bond will be broken, and we get one is RX, and another one is ROH. Again, this alcohol react with HX. We know this reaction. Alcohols and HX already seen in the chapter halogen derivative. Alcohols plus HX, we get again RX plus H2. Yes, this is anisole. Anisole is a methyl phenyl ether. When it is treated with HI, hydroiodic acid, this bond will be broken. See, the bond between oxygen and CH3 will be broken because this bond is strong. Oxygen and carbon bond is strong. This bond will be broken, and we get the phenol plus methyl iodide. This is a very important question. Many times it is asked, how will you prepare phenol by using anisole? How will you prepare phenol? So note the question carefully. How will you prepare phenol by using anisole? So we have to use here strong HI, hot HI. We get this is the same as these reactions. General reactions are shown here. So this is ROR and this is AROR. Then electrophilic substitution reactions are same like phenols, because like phenols, they only 10 minutes are remaining. So I will take first. Electrophilic substitution reactions, they are same as halogenation. Instead of this OH-OCH3, this OCH3 group is electron donating. Again, bromine in acetic acid, we get ortho para. Ortho is minor and the para is major. Then Friedel-Crafts reactions. Friedel-Crafts reactions, there are two Friedel-Crafts, one is alkylation and one is acylation. All these reactions, again, it will be repeated. These are already repeated in halogen derivatives. In case of phenols also, these reactions are carried out. CH3Cl, this is alkylation. When the methyl chloride is used, this is alkylation. Again, we will get the two products here. All the electrophilic substitution reactions are same. We get two products, ortho and para. CH3 is electrophile. Here CH3 is also electrophile. Para is major because there is no steric hindrance. Then this is a Friedel-Crafts acylation because acetyl chloride is used here. CH3CO is electrophile. It is attached ortho para. Again, the para is major, ortho is minor. In case of nitration, again there we will get two products is para and ortho. The para is major. Nitrating mixture. Conditions are same. Nitration of phenol is same, nitration of anisole is same, nitration of chlorobenzene is same, nitration of benzene is same. All the nitration reactions are same. We get the product NO2 group is attached, but this NO2 group is attached to the ortho or para. This is depend upon the group attached to the benzene ring. If this group attached to the benzene ring is electron donating, we get ortho para products, and group attached to the benzene ring is electron withdrawing, we get meta products. If instead of this OCH3, if NO2 group is attached, we get only one meta product is there. So the chapter is completed here. Then uses of alcohols, phenols, and ethers. This is as for 2 marks. Uses of alcohols, there are two different alcohols, methanol and ethanol. This is methyl alcohol, this is ethyl alcohol. Methyl alcohol it is used as a solvent in case of many industries for oils, fats, gums, cellulites. It is also used as a dry cleaning agents, preparation of perfumes, in deodorants and perfumes. This methyl alcohol is used. Also, it is antifreeze agent for automobiles, radiators in cold countries. In cold countries like Russia, for the automobiles, radiators, this is used as anti-freezing agent. So due to this ethyl alcohol, freezing do not occurs. It also used as a starting material for the preparation of many organic reactions like methyl chloride, dimethyl sulfate, and formaldehyde. Out of these 10 uses, we have to remember any 4, because in board exam, the question is asked like this: write any 4 uses of alcohols. They will not mention methanol and ethanol. For your understanding purpose, I have given this methanol and ethanol. Ethanol, it is used as mainly in beverages, in rum, whiskey, and beers. All these alcohols are ethanols. Remember, it is also used for a solvent for dyes, oils, again perfumes, cosmetics. In perfumes, methanol is also used and ethanol is also used. But the main use of ethanol is a mixture of 10 to 20% ethanol with petrol. It can be used as a fuel. Nowadays, we are using alcohol. This experiment is already going on. We are mixing ethanol, 10 to 20% ethanol in the petrol. So it is a very good motor fuel. Then it is an effective antiseptic and used as a ingredient in many mouthwashes. Nowadays, due to the COVID-19 situation, for the sanitizer purpose, this ethanol is also used. It is used as a starting material for the preparation of iodoform, chloroform, acetic acid, and ethers. Then uses of phenols. The main use of phenol, it is mainly used as a uh, antiseptics, and it is also used for what you can say, disinfectant. So phenol is used for the preparation of phenol formaldehyde polymer, mainly bakelite. This we will discuss in the chapter number 15, polymers, introduction to the polymer chemistry. We will discuss this one, how the bakelites are prepared by using phenol and formaldehyde. Phenols are also used as antiseptic in common products like air fresheners, deodorants, mouthwash, calamine lotions, floor cleaners like Lysol. Then in case of Detolls, it is used preparation of phenolphthalein indicator, and certain dyes it is used preparation of drugs like salicylic acid, aspirin. So remember any 4 uses or any 2 uses in your textbook. Only 2 uses are given. Additionally, I have given the 2 uses. Then ethers. Diethyl ether was used as a general anesthetic in surgical operations. Anesthesia means for the operation purpose. Anesthesia is given. In older days, this is used. Nowadays, it is not used. Diethyl ether is used as a solvent for the Grignard reagents. Then word synthesis, it is used as a solvent. It is also used as a refrigerant for cooling the reaction mixture. It is used. A mixture of diethyl ether and ethyl alcohol. Remember this mixture, diethyl ether and ethanol. It is used as a natellite, and it is used for substituent for petrol. Natellite, it is used as a fuel. It can be used as a substituent for petrol. So this chapter is completed. I will again take a quick review. Yes. Again, I will take a quick review of this chapter. One exercise is also given, and also I have sent this PPT to you. This is already mailed. So those students who are preparing for board exam, they already started their preparation. So solve this exercise. I have given the questions which are not given in your textbooks. These questions I have taken from different books. So today's exercise for you, solve these questions. I have given many questions which are asked for JEE exam, NEET exam, and different competitive exams. So go through all these questions we can solve. If you have any difficulties, you can ask me. So this chapter is for 6 marks with option. If you prepared the 2 chapters, halogen derivatives and this alcohol phenols ethers, this is purely organic chemistry, we can get the 10 marks. And in practical, if you get the 28 marks, you become pass in board exam if you prepare these 2 chapters carefully. So again, I will make a quick review of this chapter. What is the important questions mainly as for board exam? One thing I want to tell you, in this chapter there are 3 functional groups are used: alcohols, phenols, and ethers. Alcohols, there are 2 marks question. On phenols there is a 2 marks question, and for ethers there are 2 marks question. So we can't skip any part in this chapter. 2 marks. Already I have removed the part which is a non-evaluative or deleted for this due to the COVID-19. I didn't make slides of that part. So whatever the slides I have given in this PPT presentation, all the slides are asked for board exam. So this Grignard reagent reaction is very important. Remember, this Grignard reagent reaction is very important. This is many times asked for board exam. So make a practice of this reaction. This is asked for 2 marks in alcohols. So in alcohols, the reaction of this hydroboration, this is asked for many times. This is anti-Markovnikov's addition. So make a practice of this reaction very well. Then Dow process many times asked, Dow process, and then cumene. All the reactions of phenols are important. This is benzene sulfonic acid is important. Then this is benzene diazonium chloride is important. So preparation, we have to start the preparation after finishing the chapters. Read the chapters thoroughly, read the presentation thoroughly. If you have any doubt, then ask me. Daily we have to do the revision of organic chemistry. It is not like physics or it is not like mathematics. Daily we have to make a practice, unless in the month of November and December it will be volatile. So I will stop here. After tomorrow there is no lecture. Day after tomorrow we will start the next chapter. This is aldehydes.